Following on from the previous video, when x equals 2, we would put it into here. This thing here, 2 take away 1, that would be 1. 1 times n, that would be your n. So when x equals 1, we need to determine if this will converge or if this will diverge. So we should use the nth term test. In order for any series to converge, the limit must head towards 0. 0. As it turns out, the limit of this thing here doesn't head towards 0, so we know it's going to diverge, but we need to see that. So we need to find the limit of this. So in the previous video, we got to this stage here. As it turns out, we can rewrite this as this. So you can see that this thing here is this thing here, which is your e here. So this is actually 1 over e. But we need to be able to see how we can get from here to here. So if you look at this, imagine this to be a and this to be b. So you've got a over b to the power of n. And then if you imagine this as being 1 over, so that's this 1 here, 1 over, and then this thing here is actually your a here, a, and then this is actually your b here, and then you've got to the power of n. So basically, I need to show you how you can get from here to here. So that's the same as me showing you how to get from here to here. So looking at this, so I need to show you how to get from here to here. So imagine this, imagine this to be a to the power of n over b to the power of n. And then if you look at this here, if you look at this here, you've got 1 over. Let's look at this bit here. So that's the same as b to the power of n over a to the power of n. So you've got one thing divided by another thing. So you've got that number 1 divided by this thing here, which is bn over an. Well, that's the same as times in the reciprocal, an over bn. So 1 times anything, that will be that same thing. So this is an, which is this thing here, an, a to the power of n, and then b to the power of n. The point here is that this is the same as this. Okay, so hang on. So you can actually rewrite this as 1 over and then turn this bit upside down. So turn this bit upside down and so on. You can get from here to here. Okay, so now if you look at this here, this is like your number 1 here. So that's this 1 here, n over n. And then if you break up this fraction here, you've got plus 1 over n. This is 1 over n. So this block here, and then you've got your n here, you've got your n here. So this block here is the number e, So you've got your 1 over, this whole block here is the number e. So this thing here, going back to here, this thing here is actually equal to 1 over e. So what that means is that the limit of this thing here, equals 1 over e. You see, if you look at this, in order for any series to converge, the limit as n heads towards infinity must head towards 0. But here it's heading towards a number. So you've got, I don't know what it looks like, but you've got something that heads towards 1 over e. So here you're adding 1 over e to this thing. You're adding another 1 over e. You're adding another. It's never going to converge. In order for it to converge, it must head towards 0. So we can conclude that when x equals 2, the series will diverge. Okay, so now we need to consider what happens when x equals 0. So hang on. So far we know that anything in between we know it's going to converge. When it equals precisely 2, we've just established that it's going to diverge when it equals 2. So now we need to consider what happens when it equals 0. So when it equals 0, hang on, when x equals 0, you would put this into here, into the x. So 0 take away 1, that would be negative 1. So this thing here would be negative 1. And then this n here would be, well, it would stay the same. So now, you can break in, here, and then you can break into here. So that would then be this to the power of n, and then the bottom to the power of n, and then this, so that would then give you negative 1 to the power of n. That would then give you n to the power of n, and then let me think, and then you can take this out. So you've got one thing here multiplying with another thing here. So you turn this back into this. So now this is what we had earlier. Remember, we spent ages establishing that the limit of this as n heads towards infinity is equal to 1 over e. So here you've got something that alternates, and it's 1 over e. So what you've got here is, let's say this is 1 over e, this is negative 1 over e. So this alternating thing, hang on. So let's say this alternating, let's just say something like this. This alternating thing it jumps back and forth like this. So here you're adding a positive amount to your whole summation, and then you're taking away an amount from that summation, and then you're adding another amount. You see, it's never going to converge, because you're always going to add this amount, take away this amount, add this amount, take away this amount. It's never going to converge. So we can conclude that because this thing here is 1 over e, even though it's alternating, it's never going to converge. So we can conclude that it's going to diverge. So after all that, anything in this interval, it will converge. And then we check that for dead on 2 is going to diverge, for dead on 0 is going to diverge. So this is our domain really. Anything in between here is going to converge. Dead on 2 is going to diverge. Dead on 0 is going to diverge. Okay.